x equals cos t minus t and y equals sine t. We're going to look at this curve just in this range of t here from 0 to pi and find the turning points and investigate their nature. So here, dx dt then is equal to cos goes to minus sine t. T differentiates to 1 and it's a minus 1, isn't it? There's a minus there. dy dt. Sine differentiates to cosine of t. So dy dx then is equal to, okay, so let's have a look at this. Dy dt divided by dx dt is cos t. Cosine t divided by, and take the minus outside, and we can write that as 1 plus sine t underneath, yeah? So that equals 0 when cosine t equals 0. So in other words, in this range here, from 0 to pi, the cosine function, remember what it looks like? Do a little sketch of it here. There it is there. So that's pi over, there's pi over 2, and there's pi here. So it equals 0 at pi over 2. The denominator is non-zero at pi over 2 because sine is 1. So we do get 0 on top over a number which is 0. So that's fine. So we check that. So a turning point at t equals pi over 2. So at t equals pi over 2 then, our xy coordinate turning point is equal to, cos of pi over 2 is 0, so we'll just get the minus pi over 2 on the x value, and the y value will be sine of t. Sine pi over 2 is 1. So here's our turning point. We want to know whether it's a maximum or a minimum. Now as t increases through pi over 2, the value of pi over 2, what happens to x? Does it increase or decrease? Well, x is cos t minus t. This is small, 0 essentially, almost 0 or thereabouts. But this is the dominant term at the value t equals pi over 2. We've got a minus in front of it. So because it's a minus, it flips the way that it doesn't increase, it decreases, doesn't it? Because we've got minus the values. So 0.9 would be minus 0.9. And then 1.1 would be minus 1.1. So as the 0.9 increases to 1.1, the minus 0.9 decreases to minus 1.1. So x decreases. So we need to read the dy dx in the reverse direction, or orientation, so to speak. So here, dy dx then is equal to cosine t over minus 1 plus sine t. Now that equals, now I'm just going to look at it now very casually at t slightly less than pi over 2. And I'm going to look at it as t is slightly bigger than pi over 2. So around this area here, and what's the value of dy dx? For less than pi over 2, this is positive, the sign is positive, it's almost 1. So you've got a positive over a positive because this is acute, but there's a negative here. So positive over negative is a negative. And for bigger than pi over 2, that's when this becomes negative. This is still positive underneath. Negative over, and there's a minus here, negative makes it a positive. So I hope you could see that. So as t increases, we go from a negative to a positive slope. But the point is that x decreases. So we have to read this around the reverse direction. So we're going from a negative slope to a positive slope. So it's going to be a minimum. So we have a minimum. That's what I think we have. Let's just check that again. So we said as t was, that was negative. So, oh, hang on. No, I'm not right there. I've got that wrong. Because we have to read this in the reverse direction. On the left-hand side of x, we're going to have the positive value, like so. And on the right-hand side of x, which this corresponds to, we have a negative. So we have a max. A maximum. Sorry about that. Easy mistake to make, though, because it reverses. This would have produced a negative, but we read it in the reverse direction, so it produces a maximum. Okay, so we have a max at the point minus pi over 2 and 1. So we need to confirm that. Let's get our plotter out, our parametric plotter, just to verify we're okay with that. So I've typed in all the entries here, cos t minus t sine t, go from 0 to pi, and let's see if we get our max. Here we go, here it is here, and the value was 1 minus pi over 2, 1, we have a max. Yep, that's fine.